that same lesson. It's 5.4. So I'll write 5.4 right here. Section 5.4. And I'll put a letter B after it because this is our second part of 5.4. All right. And so yesterday, just a quick review. Yesterday, we said that I is equal to the square root of -1. And then if we squared I, if you square this, you actually get a whole number or a real number, which is -1. All right. So we did a little bit of math with that stuff, and let me see what we're going to do now. Okay, let me introduce something that's a little bit new. Well, it's completely new, but we're going to use this for our problems. So on the problems we're going to get today, we're going to be doing some stuff with fractions, and you're going to have I in the denominator. So that's going to be a little bit tricky because remember, we cannot have square roots in the denominator. So let's go back in time a little bit to, I keep saying algebra 1, but I'm pretty sure you guys did this in algebra 1. So let me just let's do something like this. So I think this is an algebra 1, or maybe this was an algebra 2 earlier in the year. Again, I just picked this up just a week ago, so I can't remember exactly when you did this stuff, but I think it might have been algebra 2. So the deal was that you cannot have a square root in the denominator. Let me drop this thing down a little bit so I can see all my colors. There we go. All right, so we learned at some point that you cannot have a square root in the denominator, so you don't want that. I don't really know what the reason is. It's just not simplified, and somebody that came up with these rules decided that having a square root in the denominator is not considered simplified. All right, so what we're going to do is we're going to get rid of that square root in the denominator, and the way that we did that, and we do this for a lot of different things, we're really going to multiply this fraction by a 1. I'm not just going to put a 1 here because that really doesn't change anything, but we're going to multiply by something that's equal to 1. All right, so what we're going to do, I'll just show you what we did right off the bat. If you multiply this by a square root of 2, and you multiply this by a square root of 2, are we allowed to do this? Are we allowed to multiply a fraction by something over itself? Well, sure we are, because anything over itself is equal to 1, and you can multiply anything by 1 and not change the value of it. All right, so we're completely in our rights, okay, if you want to call it that, to multiply by this. Why did we choose square root of 2 over square root of 2? Was it just some random number that we picked? Well, of course not, because if you look at this, we picked a square root of 2 because this is a square root of 2. And what happens, remember our goal is to get rid of the square root. So we want to try to get rid of the square root, so we multiply it by itself, because when you multiply a square root by itself, you're basically squaring it. So let's just go off to the side. So when I multiply the square root of 2 by itself, I'm basically squaring it, and what happens with the squared and the square root? They go away. All right, they cancel each other out. Squaring a square root undoes it, and that'll get rid of the square root. So let's go back to white. Finish this little problem off. This is just a little background. This is not exactly what we're going to be doing today. Oh, why did that go so thick? That was weird. Oh my goodness. Oh, that's why. There we go. Okay, sorry. Technical difficulties. So what we're going to do is multiply by the top. So we got a 3 times the square root of 2. Multiply the bottom. We already figured that out. Square root of 2 times square root of 2 is 2. This is considered simplified. All right, so you may have a problem where you have to do a bunch of stuff and you end up with something like this, but you always want to completely simplify it. And this is what math teachers considered completely simplified and not having a square root in the denominator. So what we're going to do today is somewhat similar to that. It's not exactly that, but it's somewhat similar to that. So let's do this. Let me give you a real number. Let's just do the one that we started with, a plus bi. Excuse me. I'm still a little groggy from just waking up. I just woke up like 20 minutes ago. It's not wine or anything. It's just grape juice. All right. So let's do this. We're going to take a real number, and what we want to do, this is a square root. I is a square root. It's not just a variable. It's a square root. So it's the square root of -1. Wow. All right, it's that morning voice I got here going. So we want to get rid of that square root. Let's say we had this, I don't know, over some or underneath a numerator. So let's say this was our denominator and we wanted to get rid of that I. So let's just do this. I'm just going to show you what happens here. What we're going to do, we're not going to multiply by a plus bi because that's not going to get rid of that that I right there. Well, it will, but it will include another I. We're not going to get into it. But what we're going to do is this. We're going to multiply by a minus bi. We have a name for this. We call this the conjugate. Conjugate. All right. So watch what happens when we take a real number. Okay, I'm sorry. When we take a complex number, remember, a complex number, we learned this yesterday, is a combination of a real part and an imaginary part. So this is a complex number. So when I multiply by a complex number, when I multiply by its conjugate, I should say, then just watch what happens. Let's see what happens. So we have what do we call this? A binomial. Okay, we have a binomial. We got these two things that are being added. We got these two things that are being subtracted from each other. So we know how to do that. Okay, it's just the FOIL method. So even though this is a square root, we can still do FOIL method with a square root. So let's do that. So we go first, outside, inside, last. So we multiply the first ones together. So a times a, that's a squared. Let's do the outside. The outside is a times negative bi. That's actually pretty easy. So it's negative a bi. Let's do the inside. So it's these two together right there. There's another a bi, but this time it's plus. So we put plus a bi. Now you should see something right here. I'm not going to give it away just yet, but you should see something right there. And then we multiply the last two terms. So it's a positive times a negative, which is going to be negative. And then we get bi times bi, which is b squared, because b times b is b squared, and then I times I is I squared. All right, let's keep working this out and simplify it, because it simplifies to something to be really pretty easy. All right, so remember what I said right here. What happens here? Negative abi plus abi, that gets rid of this. They add up to 0. I've got a squared minus, now let's come over here. Before I write this down, let's figure out what this thing is right there. So negative b times I squared. We know what I squared is. I squared is just a negative 1. So I've got negative, I'm sorry, b squared, don't forget the b squared. So it's negative b squared times negative 1, which is going to be just plus, because negative times negative is positive, b squared. So it's going to be plus b squared. So that's what happens when you multiply a real number or a complex number times its conjugate. So what if you had something like this? I'm going to, before we get to the official first example, let me just make something up here. What if we had 2 minus 3i, okay, and we wanted to multiply this. They don't ask you this on a homework problem, but we're going to have to do this step in order to answer our actual homework problems. So what if we had 2 minus 3i? What's the conjugate of that? Well, it would just be the opposite sign. It's the same exact thing. It's just the opposite sign. It's not always going to be a plus. I'm going to show you an example in a second. So it's going to be 2 plus 3i. That's multiplying by the conjugate. Let's work this thing out and see how to do this. We can do this pretty quick. So 2 times 2 is 4. Now, you know the outside and the inside are going to add up to 0, just like they did right here, because this a and b stuff represents any number at all. So if I go 2 times 3i, that's 6i, and this is going to be minus 6i, so 6i negative 6i is 0. So you know the outside and inside are going to add up to 0. So we basically just end up multiplying the first terms and the last terms, because the inside terms right here are going to add up to 0. All right, hope that makes sense. So we go minus, and then 3 times 3 is 9, and then I times I is I squared. Let's just, now you might even be able to do this in your head right here and skip this step, but I'm going to just show all the steps since it's kind of new. So negative 9, and that's negative 1, and that's 4 plus 9, and that gives you 13. So that's how you would multiply by the conjugate. What we're going to do today is this stuff, this like 2 minus 3i, is going to be in the denominator, and we need to get rid of the denominator kind of like what I showed you before. So let's do another one. What if I had 3 plus 5i? What if that was in your denominator and you needed to get rid of the I, the square root of -1, in the denominator? Okay, well, you're going to multiply this by its conjugate. So this time we started off with a plus. Well, actually, I don't even have to do this because I started off with a negative. The conjugate is just the opposite sign in the middle of this. I started off with a negative here. I started off with a positive here. So either way you do it. So what you would do is just multiply by 3 minus 5i, go through this, multiply it together. Can we do this in our head? Let's just go ahead and do it. So remember, the outside and inside add up to 0, so I don't have to worry about that. So the first is just 9. The last is minus 25i squared. So minus 25i squared would be the same as plus 25, and that would give you a 34. So that's how you would do that. Said I wasn't going to do it, but I ended up doing it anyway. All right, enough of that. That was just to get us warmed up, okay? But we are going to do stuff like that right now with the first example. So the first example, all these say simplify. When I say the first example, it's technically example 7 in the book, okay? So it says to simplify, and here we go. We got a 2i over, and then it's 3 plus 6i. All right. So you have an I on the top and an I on the bottom. Now, an I on the top is fine. That's perfectly fine to have a I or a square root in the numerator. No problem with that. The problem is this right here, the I in the denominator. Remember, it's not simplified if we have a square root in the denominator, and that's what the I is. It's not a variable, it's an actual number. It's an imaginary number, but it is a number that that equals the square root of -1, and we cannot have that in the denominator. Well, we just learned a little trick in order to get rid of that square root. And look, this is in the denominator now, so what we're going to do a combination of both things that we learned today. So we're going to take this 3 plus 6i and multiply it by its conjugate. Multiplying a complex number by its conjugate will get rid of that square root, or that I. So we multiply by 3 minus 6i. And then, of course, we got to do the same to the top. The reason that we do this on the top is because what's in pink right here, it basically boils down to just +1. So we're multiplying by 1. We're not changing the value of this at all. And let's see what happens. I'll tell you what, let's do the top first. So we're going to take this. The reason I put this in parentheses is because this 2i is being multiplied by the sum right here, so we have to distribute here. So 2i times 3 is 6i minus 2i times 6i. So 2 times 6 is 12. I times I is I squared. You may be able to do that in your head. That's fine if you can. I'm going to write it out just because I'm teaching it for the first time. Let's do this down here. Let's multiply by the conjugate. Well, the nice thing about multiplying by the conjugate is that the middle terms add up to 0. So let's take the first and the last and multiply them together. So 3 times 3 is 9. The middle terms, the outside and inside, add up to 0. So basically, you just do the first and the last. We got minus 6 times 6 is 36. And then I times I is I squared. Now, again, you may have been able to do this and this in your head, but I'm just showing all the steps just to be careful. And here we go. So now we're going to do this step. So it's -12 times I squared. Remember what I squared is. I squared is -1. Now, if you wanted to do this step and make a whole new step and put this in there, that's fine, but that's what this thing is right there. It's -12 times I squared, and what's that? It's just a +12. All right, and then you do the same thing to the bottom. So you've got a 9, and then this is minus 36i squared. Again, what is this? This is -36 times -1, which is actually a +36, which gives you what? A 40. Actually, let's write that. Well, let's just do that. We can do that in our head. So 9 plus 36 is what? 45. All right, there we go. We're not finished yet, though, because we always have to simplify. So let's simplify this. How in the world is this not simplified right now? Well, if I look at this, I can factor out a common factor here. So look at the top right here. What's in common with the top? Well, 6 is, but is 6 in common with 45? No, it's not. But there's also a 3 in common with this. So what I'm going to do is basically I'm going to divide everything by 3. You could do this a couple ways, but here's what I'm going to do. I'm going to factor out a 3 from the top, and that gives me 2i plus 4. And then I'm going to write this as 3 times 15. Okay, the reason I did that is because I recognize if I factor out a 3 from this, factor out a 3 from this, the 3's will cancel, bam, bam, like this, and then this is what we have. Now, remember what complex number notation is. It's a plus bi, isn't it? Shouldn't circle, that's not really my answer, but that's our complex number notation. We always want the real number first and the imaginary number second, so all we'll do is just change the order of this. Instead of 2i plus 4, we're going to write 4 plus 2i, and that's over 15. Now, here's another thing. It depends on your teacher. I don't know how picky Mr. Rao is going to be about this, but some teachers are pretty picky on this, that you want the real number sitting there by itself, and you want the imaginary number sitting there by itself. Right now, this is kind of a combination with this 15 under both of them. So a lot of math teachers, in your book will do this as well. They want to separate these. So this is the same thing. They're both being divided by 15. So we put 2 over 15. And you could put the I up here in the numerator if you wanted. I like to kind of put it off to the side. It's the same exact thing, because if we were to multiply this together, we would just go 2 times I over 15 times 1, which would be 2i over 15. But this looks a little bit better because we want our coefficient out in front of our I. I hope that makes sense. So this is simplified. We didn't really like solve for x or anything. All we did was just simplify this thing right here. It looks completely different. I mean, look at this. I mean, hardly any of the numbers except for one of the i's and the 2 are the same. You got this 4, you got this 15. All right, it looks really different than this, but this and this are exactly the same thing, but this is now simplified. Why is it simplified and this wasn't simplified? Because of that I now is in the, this was in the denominator, and now it's not in the denominator, okay? Let me check how long this class goes to. 8:38. Okay, I got time to do one more, since it is Friday. Did anybody else pop on here? Let's see. Nope. You guys are still the only ones on? All right. Yeah. Well, I'll record it, and I kind of figured I wouldn't have too many people, but I thought I'd have more than just 2. So congratulations to both of you for showing up. All right. Let's do this. This is actually easier, to tell you the truth. 4 plus I. Usually they put the next example a little harder, but this one's a little bit easier. And this is example, this is part B of example 7. All right, so we need to simplify this. Let's write that down. Simplify, all right? If you look at this, look at the denominator. The denominator does have an I in it, so we have to get rid of the I. But there's not a sum, okay? It's not like 3 plus 5i, negative 2 plus 5i, or something like that. So we don't have to multiply by the conjugate this time. Okay, the only time that you multiply by the conjugate is if you have a sum or a complex number down here on the bottom, all right? You have a real plus an imaginary. Well, technically this is a complex number because you could look at it as 0 plus 5i. So you could still consider that a complex number. But you don't have really a sum that you're looking at. So it's actually kind of easy to get rid of that I. So what we're going to do, let me change colors. What we're going to do is multiply it. We're still going to do that same process by multiplying it by a 1 or something over itself. So, but all we have to do is get rid of that I. How can I take an I, what can I do to it to get it to be a whole number? Well, we can do what we did right at the beginning of yesterday, this whole definition of what I is equal to. So if I square an I, that's going to equal -1. And you're probably thinking, well, I can't just like randomly just square this I. Well, I'm not going to randomly square the I. What I'm going to do is multiply it by I here, and as long as I multiply the top by an I as well, then I'm allowed to do that. Okay, that works with my rules of algebra. Because again, I know I've repeated this over and over again, we're going to say it again, that I over I is equal to 1. Anything divided by itself is equal to 1, so I'm allowed to do that, okay? I'm allowed to multiply this fraction by a 1. Now, I was pretty particular about what I chose as my 1 because I want to get rid of this I. So I multiply it by an I, it's I squared, it's -1. You get the idea. I'm just repeating myself now. All right, let's keep going. So what happens here? It's 5 times I times I. I'm just going to show every step. Again, you probably can do this part in your head, but I'm going to write it out. Now, this I is being multiplied by a sum right here. It's very, very important that you multiply together. Now, some people, after me teaching multiplied by the conjugate, some people would look at this and think you had to multiply by the conjugate, but you don't, because this right here, this 4 plus I, is in the numerator. So we don't have to multiply by the conjugate if it's in the numerator. You only do that if you have that complex number down here in the denominator. You would multiply by the conjugate, okay? So that's pretty important. Right here, though, it's an easier step than what we did earlier. So let's do this multiplication. So we distribute that I, so it's going to be 4I plus I times I, which is I squared. And let's simplify this. 4I, we can't really do anything with that, but we can with this. Plus an I squared, that's -1. Plus a -1 is the same thing as just -1. We're going to write it like this. And right here, 5 times I squared. Again, let's do this in our head. I squared is -1 times 5 is -5. We don't want to write it like this because we have everything over one denominator. We want to split it up so that we have one real part and then one imaginary part with the I next to it. So we want these separated. So we're going to go -4. I'm sorry. Yeah, we could do that. You're probably looking at this and Mr. Hamrick, I thought the negative was down the bottom, but really on a fraction, doesn't matter if it's -3/2 or 3/2. Or even sticking it out in front, right in the middle. These things right here are exactly the same, okay? There's no difference between any of these. So I can write it like this. I could have put the negative right out in front. I could have kept it on the bottom, but we hardly ever keep it on the bottom if we're going to simplify this fraction, okay? Let's keep going. It's -1 divided by -5, which is a plus, and then that's 1/5. Oh, that noise you hear is my computer. I can't believe this computer is so loud. Every once in a while, I've got to cool down, I guess, and the fan comes on. It's crazy loud. All right, so, oh, I forgot something. I forgot that I, didn't I? Can't forget that, so let's put that right there. Now, this is okay, I guess, but remember our complex number form. We always want to put the real number first, the imaginary number second. This is our imaginary, so this really should go second. This should go first. So here's our final answer. It's 1/5, and then you can just put a minus right here. And then 4/5, and put a big old I right there. And that is our answer right there. We have simplified. All right. That's pretty much it. So let me do this. Let me put, you know what I'm going to do? Since you guys are the only ones that showed up today, I am not going to give you a homework assignment, but here's what it would be. So I'm going to assign this on Monday. Do we have class on Monday? Yes, we do. So I'm going to assign this on Monday. So I'll give you guys a little break because nobody else that didn't sign on today, they're not going to be doing this. So I'm not going to make you do this over the weekend. But if you want to, if you get really bored the rest of the day, and you can do these problems. But I'll probably have you guys work on this in class on Monday. After I teach this, I'm gonna have to teach this again. Sorry, but I'll have to teach this again on Monday. So I'll probably assign this on Monday. So it would be 30. What was that? That's a 3. Kind of looks weird. 33 minus 59, or 2, not minus. 33 to 59, just the odds. Okay. So this is the homework. So if you feel like doing the homework, doing half of it, doing a few problems, just because this is kind of fresh in your head. If you want to do some of these today or over the weekend, feel free to do that. If not, I'll assign it on Monday, so you'll have a little bit of a head start. All right. Let's go back to this. Nobody else came on. All right. Well, that's it. So I'll let you out a couple minutes early. Any questions? Angel, you good? Seth, how about you? You good?
Yeah.
All right.
I'm good.
All right, cool. So I will have this. I put this on YouTube, and if you go to, let's see, let's go back to this. I think I might have showed you this last time, but if you go to this and you go, where did I put that? I put that under chat, I think. If you go to chat, I think it's in a couple places. There it is right there. See the YouTube version of it? So you could actually click on that, and this is what it looks like. So it starts off, if you go, that's college algebra class, sorry. But anyway, you get the idea. All right, that's it. Have a good day. Stay safe. See ya on
All right,
Monday.
see ya.
See ya.